Hey, my name is Josh Garrick. Today I'm talking about topics in Chem 1310. We're going to be talking about Lewis structures today, a big part of chemistry and determining later parts of chemistry. So it's a foundation you want to really understand. So just got a couple slides that have a lot of information on it, and two examples of drawing up Lewis structure, as well as the background information and how to do it. So start out with this. So Lewis structures are used to represent covalent bonding, also called Lewis dot diagrams. They show the bonding of a molecule in the lone pairs of electrons that may exist in the molecule. A Lewis structure can be drawn for any covalently bonded molecule. It's named after Gilbert N. Lewis, who introduced it in a 1916 article called The Atom and the Molecule. The Lewis model assumes that the electron pairs in a molecule are localized on a particular atom or in the space between two atoms. So it can't be a rule, it's a guideline. That's the main thing with Lewis structures and Lewis dot diagrams. So now we have a couple of guidelines going into Lewis structures. Again, not rules, because they're not going to work for every setup that we have, but they are guidelines that will work a lot of the time. So we want to start. Count up the total number of valence electrons available. You want to add up the group numbers of all the atoms present, and if the species is a negative ion, add to the total charge, and if it's positive, subtract from it. Okay, so then you want to calculate the total number of electrons needed. Now, that first step is symbolized by A, and this step is symbolized by N in our examples to come up. But for each atom to have its own noble gas set of electrons around it, it's going to be 2 for hydrogen, 8 for elements from carbon on in the periodic table. 3, you want to subtract the numbers from step 1 and step 2, and this is the number of shared electrons, the bonding electrons, which is represented by S. Number 4, you want to assign 2 bonding electrons as one shared pair to each connection between 2 atoms in the molecular ion. And on step 5, if any of the electrons earmarked for sharing remain, assign them in pairs by making some of the bonds double or triple bonds. In some cases, there may be more than one way to do this. And in general, double bonds form only between atoms of carbon, nitrogen, oxygen, and sulfur. 6, we want to assign the remaining electrons as lone pairs to atoms, giving octets to all atoms except hydrogen. Alright, so now we're going to go through 2 examples of drawing Lewis structures. Our first example is for a molecule, an atom of CH4. And our second one is C2H4. So they're gonna be a little different, but the process coming up is what we're really trying to go for. So in our first example, step 1, you want to calculate A, which is the total number of valence electrons. So you've got C, you've got H. It's going to be there's 4 for C, 4 for H. Total is going to be 8. Moving on to our next step, we want to calculate N, which is the total number of electrons needed. So that's going to be, you've got 8 for N, 2 for H. So total you're going to get 16. Now we want to find the number of bonding electrons. So we're going to subtract the 2 numbers that we've already calculated, N and A. So S is going to be 8. And then here we're going to assign 2 bonding electrons as one shared pair to each connection. So as you can see in this diagram we have here, we have C, 2, 4, 6, 8. Alright, so we've got 8 shared electrons. And that's how many we had total. So that uses up them all and gives all of our atoms in here an octet. stable octet. So that's our Lewis structure for CH4. That one's relatively simple. This one's a little bit more complicated. Not much though. Still not too hard. Still just trying to go over the basics here. But we have C2H4. So again, we're going to calculate A, the total number of valence electrons available. So that's going to be 12 from looking at C and looking at H. The number of C we have, which is going to be 2, it's group 4. It's going to be 8 total. Group 1 hydrogen, we got 4 of those, 4 total, 12 total in the end. Okay, so next steps, we want to calculate N, the total number of electrons needed. So we've got, as you can see down here, for carbon, 2 times 8, and that's going to be 16, and we've got NH, so we're going to have 8, add those two together. Our N total is 24. Okay, so next steps, subtract the number in step 1 from the number in step 2 to get the number of shared electrons again. So we're going to take that, S equals N minus A, 24 minus 12 is 12. So we've got 12 shared electrons in this. Assign the bonding electrons, so we're going to have 10 used and 2 remaining. So with those 2 remaining, we're going to form a double bond. So as you can see over here, we've got 2, 4, 6, 8, 10 if we put a single bond between the 2 C's. But in order to give them both a full octet, we're just going to form a double bond in the middle here. So we've got everything with a stable octet once again. So that's again just reiterating that we wanted to form a double bond. So that's the electron Lewis dot structure of C2H4. So those are 2 examples and the background and a little bit of information on drawing Lewis structures and how it all works. I hope that helps out a little bit. Thanks.